Next, I'm going to tell you about proactive monitoring and how the proactive monitoring is able to forecast the future for performance counters instead of being reactive and constantly firefighting the problems. So this is really my favorite topic, and it's really a golden nugget in performance monitoring. So level 5 is in performance monitoring is predictive alerting. And it's a trend-based alerting mechanism such as linear regression or exponential curve for certain performance counter. Let's think about a certain SQL server that for which we don't want the average momentum of that performance counter never exceed a 60% threshold level. Why average momentum? Because we are talking about trends. So now we are having, for example, 1 hour granularity in our forecast. And the first hour is going to bring us a result of 20% CPU utilization. Next hour that is measured for that performance counter is 30%. And next hour, we are getting a 40% value for that performance counter. And if we have a 3-hour time window for our linear regression forecast history, we are going to see that linear regression curve drawn between these dots shows that next hour it will be in very high probability 50%, and next hour it will be 60%, assuming that this resource utilization is going to be straight lined over that time period. So then we can notice that within 2 hours, the average momentum of the performance counter exceeds 60%. So it's time for an alert that says that, okay, we have a proactive predictive alert that says that based on linear regression, there's a high probability that within 2 hours, we will get an alert for this particular performance counter. And now, what is also important to understand in predictive alerting, it's that we can combine different curves that have the best fit for this history that we have surveilled. And based on that, we can select, instead of, for example, linear regression, we can select exponential curve and say that, okay, actually we are going to hit the 60% mark a bit earlier on, for example. Also, if the system is very volatile, we want to shorten the time window to make the analysis of the average momentum of performance counter, because if linear regression has a longer time window, it's maybe not able to understand those changes in CPU utilization in the short term. It may show actually even that there is no change at all in average momentum of that performance counter over a long period of time, even though there are high waves, high ups and lows in a shorter time window. In that particular case, we want to adjust a linear regression time window into a shorter one. So what are the pros of predictive alerting? Well, it's a proactive view to future, and we are able to prevent the performance problems even they occur, before they occur. And the cons is that it may give sometimes a false alert. That's understandable. For example, if we have a 3-hour history data of performance counter of CPU utilization peaking, and then after that 3rd hour, the next hour is actually a lesser CPU utilization. It may happen. it sometimes happens because the CPU may first uptrending and then it's downtrending. That would be normal for that particular case. We have mechanisms to recognize this kind of more sophisticated mechanisms as well, and I'm going to tell about that also in the later slides. But that's a special case. Typically, linear regression and exponential curve are very good and simple statistical alerting mechanisms when it comes to proactiveness in performance counter predictions. And also one of the cons is that you may not be able to predict rapid changes. This means that linear regression is always a certain compromise of data points that it's looking. So in that way, the very rapid changes in CPU utilization, for example, may be not tracked there. But also for that kind of situation, we have other allergen mechanisms that have a better grip